Okay, we're going to look at some calculated problems, and these are ones we did in class. And what we're going to try to do is evaluate or find the value of these limits. Now, if we try to do substitution for the first one, the limit as x approaches 1 of x squared minus 1 over x minus 1. If we try to evaluate this, if we put 1 in, if we just substitute, we get 1 squared, which is 1 minus 1, which is 0, over 0. 1 minus 1 is 0, so we have 0 over 0. That's an indeterminate form, so we're not going to be able to deal with that just by substitution. So we could try to graph it and see what it looks like, and then use tables to kind of give us a numerical idea of what's happening. So we'll get out our calculator, and we'll turn it on. And the first thing you need to check is go check your mode. Make sure that your mode is in radians. Like if you turn your calculator on and you see it's in degrees like this, you have to change that. So all you do is just scroll down here to radians, and as that's flashing, as soon as that's flashing, just hit enter, and that's going to change it. Then you can go up to just double check to make sure your mode is radians. Okay. Then we'll go to our graphing mode, and this is y1, and we'll put our function in. Now, remember, when you're going to do fractions, you have to make sure you enclose the numerator and the denominator with parentheses if you have more than one term in the top or the bottom of a fraction. Otherwise, your calculator will miscalculate. So I'm going to put a parentheses, and I want to remember we want to graph x squared minus 1 over x minus 1. So we'll put a parentheses, and then we'll just hit x, and then if we want the square, we can hit this square over here. It's x squared. And we have minus 1, parentheses, and that's my numerator, divided by, and I have to put a parentheses there, parentheses, x minus 1, parentheses, and there's my function. So I'm in good shape. Now if I want to look at this, I'll just hit graph, and there we go. And you can see as x approaches 1, it looks like we're real close to 2. It looks like we're approaching 2 from both directions. As x approaches 1 from the left, I'm approaching 2. And x approaches 1 from the right, I'm approaching 2, but we have a hole there. But we have a pretty good graphic feel for that we do have a limit at x equals 2. Now we can check that by using tables of values. And this is real easy on these calculators now. What we'll do is we'll go to second table. And what that does is that's going to give me values based upon that function that I put into y1. And we're going to see what's happening at x equals 1. So we'll start at 0. And this is the table start. So this is where we start our table. So we'll start at 0. And we'll approach 1, and I'll go by tenths. So I'll go down this place, and I'll make it 0.1, which is already set up, I think, from today. So 0.1. And this is delta table. That's my change. So we set up at 0, we're going to start at 0, and we're going to go by increments of 1/10 to the right. I'm going to keep adding that as positive. If I want to go to the left, I can make that negative. And let's see now these are automatic. Now if we put asked, I would have to push these little arrows down to get values, but since this is automatic, it will compute it just as long as I want. So I go to second, and we'll go to table, and I'm going to see my table right above graph. And as you can see, these are the values of x. 0, 0.1, 0.2, 0.3, 0.4, and these are the values of y. And you can see as x gets bigger, y gets bigger. And until I get to x equals 1, this is the curious part. When I get x equals 1, I have an error. That's because we had a hole in the graph. And then after that, I have 1.1, 1.2. And you see we're approaching, it looks like we're approaching 2 from the left. As x gets closer and closer to 1 on the left, I approach 2 from the bottom. And then if I'm going the opposite direction, as I get closer and closer to 1 on the right, 1.3, 1.2, 1.1, 1, I'm getting closer. You can see my error is because I do have a hole in it. Now if I want to get a little bit more fine-tuning, I can go back to my table, and instead of starting 1 unit away, I'll start 1/10 of a unit away. So 1/10 of a unit away from 1 would be 0.9. All right, 0.9, then 1. So that's 1/10 of a unit, and then I'm going to change my delta table, my delta x, or my change in x to 0.01. So I'm going to go by hundredths, and there are 10 hundredths and a tenth. So I'm going to make this a little bit more fine-tuned. So let's go take a look at our table. So we go second table over here. And now you can see I started at 0.9 and I'm increasing it by hundreds. So I 0.9, 0.91, 92, 93, 94, 95, 96, etc. Those are the values of x. These are the corresponding values of y, and you can see I'm getting even closer and closer to 2, 1.99, 2.01, 2.02. So this gives you an idea. So you can see as you're approaching 1 from the left or from the right, you're approaching 2 from the bottom, from the top. Okay? So that's how we can use those tables to kind of zero in on it. And then you could go back and you could go even finer. You could, instead of saying 0.9, you could start at 0.09 and go to thousandths. Okay? So that was the first one. I hope that helps.